make corrections, add formulas, you name it, feel free to do that, okay? And I did, if you showed me some work, you could have earned some partial marks, right? So every question was worth 2 marks because, quite frankly, just guessing would have not ended up very well for you. So the first one, right, it's just finding the z-score and you get a negative value, right? So that, yeah, very close, but it had to be this one. Next, normal distribution, find a percentage, right? The percent of data between these two z-scores. And some of you didn't know what to do with that because you were looking for a mean and a standard deviation. And if there's a z-score, we immediately know that this is true. You can still use normal CDF, right? And just plug in these two z-scores, 0, 1, and then you get your percentage right there, 25.7 or so. A car tire, right, has a mean life of this, standard deviation of that. And if you purchase a certain number of tires, figure out the number of tires lasting longer than 57,600 kilometers. So this was a two-part question, guys. Maybe you first should focus, well, let's figure out the percentage that we're talking about here, right? So 57,000 and above. So you could have actually put in 1,000,000 here or something like that if you wanted to. Something really big compared to this one. So you want the percentage of tires that last longer than this. That's the key word, right? And that gives you 9,772, right? 97.72%. Multiply that by 1,500 to get your number of tires, right? This is tires. And some of you went with the 98. So if I looked at the work and I was there, you got 1 out of 2. So it's a weird thing, right? Hey, how's it multiple choice and partial marks allowed? Well, I don't know. I'd like to mix them up every once in a while because that way it's not all or nothing, right? And then this one, most of you got this one right. You were given a z-score, standard deviation, and mean, so you could use this formula right here. What was it? Z times standard deviation plus the mean, right? This is the formula that you could have used there to come up with that. And then a company gives its prospective employees a basic skills test, right? The top 5% of the applicants are hired, right? And assuming it's a normal distribution, what would the minimum z-score be? So first of all, if they give you the only top 5 are accepted, that means that 95% would not be accepted. That is sort of the percentage of applicants to the left of that value that's going to cut it, right? So this should have been 0.95, 0, 1. Why 0, 1? Because it's the z-score. Allow me to give you a twist to this. Some of you, I think, did this. You could have done this in this norm, 0.95. So pay attention because I think it's important to see the connections. Oh no, sorry. You can't do it in this case. You can't do what I was trying to do here. All you have is z-score. So if it's asking for z-score, then the mean is 0 and the standard deviation is 1. Right? So I don't, like, this was never given, but because it's asking for the z-score, it's 0, 1. Okay? We know immediately that the mean is 0, standard deviation is 1. No questions asked about that. So when you get a value out of this entry, you actually get a z-score of 1.64. Okay. So 1.64 standard deviations above the mean, so to speak. Okay. So those pages were out of 10 because each being worth 2. Next, graph, for the most part, done very well. Make sure the percentages are in there. Make sure you label, right? What is this? Weight, height, time in days, time in hours, whatever. And I asked you to use the graph above to answer these. Some of you didn't. I used to mark it wrong in the past. It's like, oh, I told you, right? Use the graph. But technically, normal CDF, like if you show me the entries and they're correct, I don't see why I would mark it wrong, right? So I was a little forgiving there. But this one here, less than 1800 steps or more than this, the or implies you need to add them, right? So I wanted the probability of both of those things happening combined, so it's 2.65. Fewer than 7,800 steps, 7,800 is right here. So I just went 100 minus this, which is 2.5, right? Some of you added everything to the left, that's fine. 97.5%, there it is. This graph was done overall. I was happy. Some of you are gonna be like, what's the big deal with the zipper, right? Why? Well, in applied and pre-cal, the province is very picky with the scale. If you're not consistent, it's a -1, right? So that's how I mark. So if you're not doing the zipper, your scale is not consistent, right? You're basically jumping from here to here is 100, and all of a sudden you're going up by 15, and you're using 2 boxes. It's not consistent, right? So the zipper fixes that. It prevents us having to start from 0 and then all the way at 100, start there and move on. That would be too complicated. Okay. So bears is the y-axis, weight and pounds. I looked for that. I looked for the zipper, and use these intervals here. Don't use your midpoints. Use, especially because it's a histogram, right? So it's from 100 to 115 to 130. You're going up by 15, basically. That's the interval width, okay? And if you wanted to connect the midpoints, sure, but that would be a frequency polygon, right? So just watch out for that. Oh, let's back up a bit. Give yourselves a little pat on the back because most of you did the midpoint immediately. But somehow, sometimes maybe you forgot to, you got to go L1, L2, right? Separated by a comma. You don't do a stats calc twice. You do them at the same time. So you're entering this into L1, this into L2. Your N should have been 151, right? I should make a note here. N should have been 151. That's how you know you did it right. You considered 151 bears for figuring out the average weight and the standard deviation. Okay, so that was that. Way to go, guys. You can be guaranteed you're going to get a frequency table on the test. I'm not even going to try to surprise you there. Next page. I do tell you use your calculator to answer. So unless I ask you to graph, do not graph. Use your calculator. Okay. So percentage of boxes that weigh at most 565.8. At most means, right? You consider everything below up until that weight. So if this is your curve, you want all of this percentage, right? So 565.8 and less, basically. So you have to have a negative 10,000. I would call this negative 10,000 way on the left here somewhere, and positive 10,000 way on the right, if you want to look at it that way. These values are completely random. It depends on what kind of values I have here. If I had values in the tens of thousands here, I would probably use minus a million plus a million, right? Just to make sure it's far away removed so that you're considering everything under that curve. So the lower limit, upper limit, 86.21%. Then how many boxes would that represent, right? Because I'm using the same wording as above. So this answer as a decimal times 20,000, that's how many boxes that would represent, okay? Last Friday, right, there's a test worth 56 marks that might have thrown you off a little bit, but find a percent of students scoring less than 17 marks. So you would go from negative 10,000 all the way to 17, right? Mean standard deviation. So very small amount of students. Between two values, this is a gold mine. This one is easy. You just go lower, upper, right? So you want the percentage between these 2 points, 69.14%. What percentage of students passed? A pass would mean 28 out of 56. So you basically want to know the amount of students that got a 28 score or higher. Who scored 10,000, right? It sounds a bit ridiculous, right? But we just go and make sure we include everything. And that represents almost 75% of students passed. Okay. If only 15% of students got a greater score than you, what is your score? So 15% got a greater score than you. That should have represented 15% above, right? So it's actually, you are somewhere here and 15% scored higher than you, meaning that 85% scored below you. First of all, it should indicate inverse norm. Then you put in 0.85 mean standard deviation. Good bedtime story, eh? What if it asks you what's the z-score? If it asks you what kind of z-score did you have to make this happen, you would simply have to do this: inverse norm 0.8501. This would be the z-score. Okay, because in this case you have the percentage, so you could have found the z-score that way. Another way of having done that is just use the z-score formula, right? You could have transferred this and calculated the z-score, but both of them would have done the same thing. Okay, so just watch the wording. Russell achieved a mark of 30 on his test. Calculate his z-score, right? This minus that divided by 6, and so it's negative 33, so below average. Or, no, you could not use inverse norm here because you don't know percentage to the left, so we're good. That's what it is. So you just decide, like sometimes you can use both, sometimes just the formula for z-score. Next, the University of Toronto requires a minimum score of 160 to be admitted. Determine the percentage that would be admitted. Normal CDF, because it's asking for percentage, 160 and higher, right? So this is my mean standard deviation, so it represents 20.36% of students. At the University of Victoria, only the top 15 would be admitted. What score must a student achieve, right? So if the top 15 make it, that means that 85% do not make it, and that's what we consider the percentage to the left of the score you're interested in. To the left, in this case, means scoring below. So it's actually 161.03 marks. We don't know if it's percentage, by the way. It's LSAT is like a standardized entry exam if you want to go for law, right? Be a lawyer. And what is it? MCAT for medicine? Something like that. So next, if 2,200 applicants apply for the law program at the U of T, so that goes back to the University of Toronto here, right? So we know that this many will be approved or will make it percentage-wise. Now it's asking for applicants, right? So you multiply it by that and make sure you round it to a whole number. So about 447. If you did 448, I would have given that to you as well. But that's what you get there. And then there's always a battle between me and Miss Yosik, right? We're the applied teachers here, for the most part. So Miss Yosik's class has a 65 average, standard deviation of 5. Mr. Dirkson's class has a higher average, but a higher standard deviation. Describe them. You may use a sketch, right? You needed to show me that Mr. Dirkson's curve was flatter. If if you had them side by side, especially or on the same, I should see it, right? So I would have picked on you there. So steeper, taller curve, lower standard deviation, flatter, spread out curve, higher standard deviation, right? Yes, it does bunch up around the mean, but not the same way. Class scored lower overall because it had a right lower mean, but the scores were more consistent due to the low standard deviation. So can you please always make a, it's like, why are you saying that's lower overall? Hey, because the mean is lower. Why are you saying it's more consistent? Oh, because the standard deviation is telling me that, right? And then here, class scored higher overall, greater mean, but scores were more inconsistent due to higher standard deviation. You could also argue that Mr. Dirksen's class, there's a higher potential for somebody scoring low, right? Or very high. Like you can have outliers. That is also often the reason why your data is spread out because of outliers. Okay. And that is it. I'm gonna stop it right there.